Okay, so let's start our indexing part 4. Okay,
Yeah.
so far we have covered, right, that clustered index, non-clustered index, and how the covered index actually help, to avoid your lookup, and that help actually to improve the performance. Okay,
Mm.
so in these sessions we are going to understand those things in little bit depth level. Okay, okay,
Okay.
so now one simple question. Okay, so we heard about the identity column, right, Suma?
Yes,
That
sir.
we create
Yeah.
identity column to generate the number,
Yeah.
unique number for every, to identify
Yeah.
the row uniquely, right? So just
Primary
imagine.
key.
Yeah, yeah,
Yeah.
exactly, that's what
Mm.
I want to come to that part. Okay, primary key.
Yeah.
So now my question is, okay, so very interesting. Okay, if I create identity column, okay,
Mm.
on one table, what do you think? Will it create a clustered index on that table, or no?
Um, if you create, I did. Uh, I don't think so because whenever we use, no, it will. It will. It will. I guess
Sure.
it will.
Okay, no problem.
Mm. Clustered index, right? It will create, sir.
Okay.
By default, you're saying.
Yes, by default, I'm saying.
By default, clustered index.
If I create
Yes.
identity column,
Yeah.
okay. Yeah,
Yeah.
okay. No problem.
Because since it will be in sequence, right, sir? Like when we are doing
Yeah, yeah, yeah.
primary, yeah,
Your
identity one. Yeah.
yeah, your thought process is absolutely correct, but the answer is absolutely wrong.
Wrong.
No problem.
Yeah.
Okay, I will clear that.
Yeah.
Even I had the same concept in my mind
Mm.
when I was freshers, so I'm happy to
Yeah.
have this answer because I'm expecting this answer so that I can explain you that our
Yeah.
thought process is right, but our technically we are not correct. Okay,
Yeah.
so don't worry, I will tell you that. Okay, so now we'll understand this. Okay, in details about. Okay, so when we create identity column. Okay,
Mm.
so okay, here I will explain. When we create identity column, okay,
Yeah.
identity column is just for generating the IDs, 1, 2, 3, that record.
Mm.
Okay,
Yeah.
so that will help you to generate this number only. Okay,
Mm.
1, 2, 3, 4. These are the
Yeah.
numbers, right? So the same way in our book, we have the numbers, right? 1, 2, 3,
Mm.
4, 5 page numbers. So same way,
Yes. Mm.
identity column will help you to generate these numbers. Okay, but
Mm.
identity column will never create a primary key until and unless we are not explicitly mentioning that. Okay,
Hmm.
so I can show you
Mm.
this practical as well. Okay, so if I go here, this is my book table. Okay, let me
Mm.
drop this table. Okay, and here's my book tables, right? So here's I'm creating identity. Okay, but in that case, identity column, I have to remove all these IDs. Okay, so that it will not work in that case.
Yeah.
So I have to remove all these identity column for now. Okay, no problem. Let me create this table. Oh, sorry, drop and create. Now here I have to remove. Actually, I want to show you the different things. Actually, that's why I created
Mm.
this data, but
Yeah. Yeah.
no problem. I will cover this point as well because this is very important point because
Okay.
I don't want we go ahead with this confusion. Okay, so that's why I'm
Mm.
just trying to, you know, remove this confusion first.
Yeah.
Well,
Yes,
book
you will
ID.
have to remove book ID. Yeah.
Correct. Good catch.
Mm.
Let me execute this. Okay. Now,
Mm.
if I go and do a select star from books, get all these records. Okay. Now I created
Mm.
identity column. That's why it generates the 1, 2, 3, 4 for every new record. Okay. That's why my data
Yeah.
is in ordered sequence. But let's go here. Okay. Just here. Okay. Refresh this database. Go to your table. This is my table, right? Here you can see your index, right?
Yeah.
If you remember,
Yeah.
just click here.
Mm-hmm.
Just go to the index. Okay. Can you see any index here? No, right?
No. No.
That means there is no any index is created on this. Okay.
Got
Okay.
it. Yeah.
Yeah. So if you can go to the constraint, or you can go to the keys. Okay. You will not find anything right related to the
Mm.
index. Okay. That means if you go
Yeah.
to the columns, you will definitely find this is my book ID column. Okay. Right.
Mm.
And if you want to find if there is identity column is just click here on your table name and just alt F1. Press the alt F1. You will see here,
Mm.
right? This is the identity column and see it and
Mm.
increment is 1 1. So you can find
Mm.
this is the way you can find that identity column is there, but there is no any indexing is available here, right? Right?
Yeah.
There is no any indexing. Okay. Now, don't get confused with this primary. Okay. So this is a data located on file group. So this is related to the file group. We'll come to that part as well. Okay. In some time.
Yeah.
Sorry, what happened to my camera?
Yeah. It's off since 5 minutes, I guess.
Just a bit wrong. Okay.
Mhm.
Sure. Let me restart. Okay. Meanwhile,
Yeah.
let's continue the session.
Yeah.
Okay. So confusion is clear. Okay. Now, can you see that
Yes,
if you
sir.
create an identity column, it will only generates the data. Okay. Only generate
Mm.
uh date numbers. Okay. It will
Mm.
only generates the number. Okay. It will not create any,
Primary key.
any index. Yeah, primary
Any
key
index.
or
Yeah.
a primary key
Yeah.
or foreign
Mm.
key, whatever. It's not creating
Yeah.
any index. Okay. It will not create an index. Okay.
Mm.
So maybe just to confuse you in the interview, they may ask you this, right? So always remember, it is just to generate the data. It is just to generate the
Mm.
numbers, okay, unique numbers, and that's
Mm.
why identity column is used. Okay, clear?
Got it.
Okay.
So it doesn't matter whether it is, in
Hmm.
sequence or not in sequence. It can't create
Index.
clustered index on its own unless we create it.
Exactly. We have to
Okay.
mention it explicitly. Okay.
Yeah.
Now
Got it.
let me
Yeah.
control check all this stuff. Okay, because I want to show now something. Now we'll understand again one more important thing. Okay,
Mm.
basic. Okay, so what is heap and what is the clustered index and non-clustered index, that we'll understand. Okay, now what is the heap
Yeah.
actually? Okay, now let's go back to again basic. Okay, step number 1, right? So I have created one book tables and I have this all this data available in this book table. Okay, so I'm dropping and I'm just creating this data. Okay, now I will do select the star from books. Okay,
Mm.
this is our scenario number 1. Okay, if you remember, right, I have the book library where my all books are in not arranged in a well manners, all is
Mm.
scattered, right? There is no sequence and
Yeah.
all that stuff. Okay,
Mm.
so that means my all these books are scattered, right? Not arranged in a well manners. Okay,
Yeah.
that
Yeah.
means there is no any indexing, right?
Yeah.
There is no any sequence, right?
Mm.
So that means these books are stored on my heap. Okay, Okay,
Okay.
so there's some ways, you know, to identify if my table is stored on the heap or it is my stored on my indexing. So there's a few things. Okay, so there's two system tables. Okay, select star. Okay, from sys dot tables. This
Okay.
sys is a schema. Okay, so same way, right?
Okay.
DBO is the default schema, right? For us, DBO is the default schema, right? My book
Hmm.
table is by default created in the schema. This schema, right? So
Yeah.
if I copy and paste, okay, even if I run without DBO, it will work because
Yeah.
the default schema is DBO. Okay, so the
Hmm.
same way, what is the use of this? Okay, so let's say you're working on some projects or modules, so based on that you can create schema. Now here is a SY is a system schema, right? That means you can easily
Hmm.
identify that whatever the tables or objects under this schema, that will be part of my system schema. Okay, so that is not
Okay.
created by users. This is by default created by the system. Okay, so that is the
Got
use
it.
of
Yeah.
schema. So we'll understand this in detail. Okay, but just to give you a high level understanding of this. Okay,
Okay.
so when you sys.tables you types, you can see that this is in a green. Okay, that means it is system defined tables. Okay, so
Yeah.
you can see that the list of the tables. Can you see there is author and one books? Okay, these are the two
Books.
tables here. Okay,
Yeah.
so for now, let me remove author. Okay, I don't want to keep this right now. Okay, I'm just deleting this. Okay, now if I execute this, can you see there is only one table? Okay, so let's say in tomorrow, if you are working in IT industry, let's say there are thousands of tables. Okay, so you can
Hmm.
go and do just select start from sys.tables where my type is u. Okay, that means user created tables. Okay,
Okay.
so you
Yeah.
can find that all the list of tables. Okay, now we have created one tables, right? Book. So that's why I'm getting this as a I'm getting this here in the list, right? So now what we
Hmm.
can do, I want to check is there any indexes created on this, right? So there's one more table sys.indexes. Okay,
Yeah.
so if you execute this, you can see there's a lot of records. Okay, maybe that is related to the system tables, but I'm interested
Hmm.
in this table only, right? So if you can see here is object ID, right? So for this,
Okay.
if you pass as object ID, okay, I want to pass object ID. So what is the object ID? So from the for this table, what is the object ID that will pick up? Okay, so for this is my object ID.
Hmm.
So there is a
Okay.
relationship between them, right? Okay, so I will copy this object ID and if I will put paste here, and if I execute this, I can see that type descriptions. Can you see that type description
Heap.
is heap,
Yeah.
right? And my
Hmm.
index ID is 0. Okay, so let me copy this
Yeah.
with header and let me put here. So always remember, if my data is unordered, that means it is if my data is unordered, right? Unordered and no any index. Okay, that means
Yeah.
it is stored on heap.
Heap. Okay.
Got it?
Got it. Yeah.
So scenario number one, right? Our scenario number one, where my in library my books are in library arranged well manner. Okay, so this
Yeah.
is my scenario one. Now we'll understand after that. Let's arrange this book in orders, right? So if you remember the last
Hmm.
time we created one clustered index on this, right? So and
Yeah. Hmm.
automatically it's okay, so let's create clustered index name. We have to give the clustered index and
Hmm.
index name, right? So
Yeah.
cix underscore, let's say my table name, and then my column name, right? What is
Yeah.
my column name? Book ID,
Book ID. Yeah.
right? Book ID on book, right? This is my column.
Yeah.
Schema is not required, okay, because it is default. Books you have to add as books. Okay, still it will work. Even if you not mention the schema, still it will work. But always try to follow this best practice. Okay, add
Hmm.
your schema as well. And if I create this index now, okay, now if I go and do a select star from books, one change that I will see is that what is that? If
It
I
is
create
arranged in sequence.
exactly, it is
Yeah.
arranged in a sequence. right? Now if I go here in the books and refresh, and if I go into the book and if I go into the indexes, which index I will see?
Clustered index.
Exactly. Okay, so
Yeah.
I have that clustered index created here.
Mhm.
Okay, sounds good. Now let's go again and find into the sys.indexes for this object ID what will be the change. Okay, now if you can go and you can see now it's a heap is changed into the clustered. Got it?
Clustered. Yeah.
Exactly.
Yeah.
So now
Got
let
it.
me
Yeah.
copy this. Okay, sorry. Index ID. Let me copy this and paste it. Can you see the index ID 0 is for heap? Okay, my index ID 1 is for my clustered index. Okay, so whenever
Yeah.
you can check for easily for any tables that is that my table is on a heap, or is that my table is clustered or non-clustered, it is indexed or not indexed. Okay, so the same way, okay, let's create one more index. Okay, here, can you tell me the non-clustered index syntax?
Yeah. Create non-clustered index.
NCIX,
NCIX. Books.
correct.
Yeah. The same.
Next,
Book ID. We are doing it. No,
no,
title. Sorry, title.
yeah, no
Yeah.
problem. Yeah, so on title we are creating, right? Non-clustered index. Okay, and now I'm executing this. Sorry, I'm executing this. So it will create a non-clustered index, right? Okay, now if
Yeah.
I refresh this, I can see one more index is here. That is my non-clustered index. Okay, now let's go again to here and in sys.indexes for this object ID. This object ID belongs to my table, right? Because this is my
Yeah.
table. This is my book table, right? So this object ID uh, is this object ID is related to my books. Okay, now if I execute this, you can see one more thing, that is non-clustered index is created here. Okay,
Yeah.
so it's very simple. Using this sys.indexes tables and sys.tables table, you can find the how many indexes clustered. Obviously clustered index is only one there, but you can find out the is my table is on heap or it is clustered index, non-clustered index. You can find how many indexes are there on my tables. Okay, you can see everything about it. Okay,
Okay.
so let me copy this again and let me put here. Okay, so now you can see this is your master data now. Okay, so you can treat
Yeah.
this as a index ID 0 means it will be heap. When it's 1 it's a clustered index, and when it's a 2
Two.
that means it's a non-clustered index. Okay, so you can see the type is also there, so that is
Okay.
heap, clustered and non-clustered. Okay, so
Mm.
far so clear.
Yes, sir.
Okay, perfect. Now we'll understand that. Have you heard any times that about the binary tree? What is binary tree? That when you create a clustered index there is binary tree, your data is into the leaf node, like that stuff. Have you heard it ever before? No, right?
No, sir.
It's okay, absolutely fine. Okay, so we'll understand this now. Okay, so when we create a clustered index, and when we create a clustered index and non-clustered index, our data is get stored into the get stored, okay, into the binary tree format. Okay, actually, so that
Okay.
actually help us to speed up the performance. Okay, so to explain this I have one small diagram with me. Okay, and that will clearly mention you. Okay, so we'll understand here what is clustered index and how this data is get stored on this disk and database, that will understand. Okay, so before that,
Okay.
okay, so we'll understand what is the binary tree structure. Okay, so now imagine, okay, so binary tree structure means actually it's a balanced tree which is improved version of your binary tree structures. Okay, so generally when we create a primary key or foreign key, that clustered and a non-clustered index is created. Okay, sorry, not
Okay.
primary key, foreign key, I'm sorry, I mean when we create a clustered index and non-clustered index, that times your data is get arranged right in indexing order. So
Yeah.
actually your data is get stored in balanced format actually. Okay, So
Hmm.
so in interviews sometimes they might ask you what is balanced tree, what is a binary tree. Okay, so actually binary
Okay.
tree structure, actually it's a balanced tree. Okay, so that is
Okay.
improved version of your balanced tree. Okay, so how the
Got it.
balanced tree
Yeah.
works, that I will give the one example. Okay, now let's say I have the 500 books in my library. Okay, just imagine you have one library having the 500 books, but you don't
Hmm.
know. Let's assume that you have the 1 lakh books in the book library, and you have to
Okay.
find all books are scattered. This is scenario number one, because you don't know anything, right? Second is,
Hmm.
second scenario is that book is arranged, okay, in a sequence, but still it's problem for you because you have to scan every single records. Only it will be faster for you
Hmm.
because it is indexing well. Okay, but what
Yeah.
if along with that, if you have some map, okay, let's say you have the 1 lakh books, the 1 to 50,000 books in the left sections, or 50 to 1 lakh books in the right sections. Okay,
Hmm.
so just imagine, directly it will cut down your 50% search, right?
Hmm. Yeah.
Right? If I ask you to find the books
Got
which
it.
is at number
Yeah.
80,000, so definitely you will just
Hmm.
go through left or right, right? The same way,
Hmm.
the
Hmm.
same technique is used here. Okay, so that's what we call it is the balance tree, or you can
Fine.
call it a binary tree structure. Okay, so actually people used to call it as a binary tree structure, but on top of this binary tree structure, it's a balanced tree structure actually. Okay, so we will understand what is balanced tree structures, how it is implemented, the things
Hmm.
going internally. Okay, so just imagine you have the 500 books. Okay, so
Okay.
if so balanced tree means, let's say you have 1000 books, right?
Hmm.
So what is the median of that, center
The
of this
500.
500, right?
500.
So
Yeah.
that's why it's called as balanced. Okay, because it's
Yeah.
do balanced tree actually. Okay,
Yeah.
so now it's a center will be your 500. It will tell that if you want to go less than 500, go to the left. If you have the greater than 500, go to the
Hmm.
right sections. Okay,
Yeah.
then it will start with 250 and then 750. Okay, so again here will be,
Hmm.
you have some combinations. Okay, so that if your values is
Hmm.
from 1000 to 249,
Wind.
go to this side, otherwise go to this side, like this. Okay, so it
Hmm.
will help you to reduce your scans, right?
Got it. Yeah.
Same like in the library, instead of
Hmm.
searching for 1 lakh books, it will help you to shorten your
Hmm.
searching, right? The same way it will
Hmm.
work. Okay, and the last row here you will actually find your data. Okay, so
Okay.
these are my root node. This will be my root
Hmm.
node. This will be my intermediate node, and this will be my
Hmm.
actual data. Okay,
Okay.
so how you can correlate this? How you can correlate this with your real-time example? If I explain you that
Hmm.
root is nothing but your indexing, right? At the back of the page you have the indexing, right?
Hmm.
Logical index, like that.
Hmm.
Your intermediate, these are nothing but the intermediates pages. Okay,
Hmm.
so these are the, in intermediates it will help you to have that compartments and the sections, left, right, less than, greater than. So this will be your intermediates. Okay, and in the
Yeah.
root, in the leaf node, okay, you will directly find the data, actual data. So
Yeah.
in the indexing, let's say I have the chapter list, and in the chapters they have given the page numbers. So at the page number you will actually find the data, right? You will find actual page, right? So your leaf
Yeah.
node is nothing but, the actual data.
Hmm.
Got it?
Got it. Yeah.
So when you create a clustered index, right? So as I said, that clustered index is only one clustered index you can create on your table, right? So that means in clustered index, your data is stored on the root, directly on the leaf level. Okay.
Okay.
So it's a root level. So you will find the data pages, actual data pages here. Okay,
Hmm.
and in the
Yeah.
root and the intermediates you will find these pages, right? So that will nothing but the indexing to help you to reduce the sections, left, right, and less than, greater than. That will help you to reduce your search. Okay,
Yeah.
so got it?
Got it. Got it. Yeah.
Okay, so this is how the balance tree or binary tree work. Okay,
Hmm.
and if I can show you uh, so along with that, just to add, okay, how data is get stored on disk and what is the data. Okay, so now again,
Hmm.
just imagine a real-time scenario, right? So anyways, your book is unordered or ordered, anyways it will store in your library, right?
Yeah.
Yeah, the same way, your books, same way your data is stored in a disk. Okay,
Hmm.
no
Okay.
matter it is ordered or unordered. If it is unordered,
Hmm.
it will store on heap. If it is unordered, it is ordered, it will store into the indexing format, and again in the indexings it will store in the clustered and the non-clustered indexes. Okay, and so
Okay.
your data is stored in the anyways your data is get stored on your disk. Okay, so if I can show you, if you just go to your database, okay, just right click here and go to the properties. Okay, and just go to the files. Okay,
Hmm.
you can see this is the path. Okay, see program files.
Hmm.
Okay,
Yeah.
MySQL servers and data files. So you can see there's one MDF extension, one is LDF. So MDF is for my master data files, and log, this is LDF
Okay.
is for my log data files. So whenever you
Okay.
create one database, okay, on SQL, even though here SQL, okay, if you can see here, mm, right, here in the SSMS you can see that this is my data, right, actually, but this is just a presentation of your data. Okay,
Hmm.
this SSMS is just a SSMS. Okay, it is just presentation of your data in a raw format, just to
Okay.
understand in a end user point of view, right? The technical person should understand this data, visualize the data,
Yeah.
but this data is actually stored into the database, right, in a page format. Okay, in a data page. So if you can see here that the data is stored on disk and it is stored in a database. So every page is 8 KB. Okay, so 8 KB page. So it,
Okay.
no matter it's 1
Hmm.
GB data, 2 GB data, or 100 GB data, it will always stored with 8 KB logical page. Okay,
Okay.
so we'll
Hmm.
understand in detail about the page later, but just to add about how the data is stored on a disk, what is
Hmm.
the pages. Okay, so as I showed you, right, so let's go here and see here. Okay, C column, then program files, then Microsoft SQL Server, right? And here, what is the path actually? You can see